So this is your video for your Chapter 15 Classification of Matter Study Guide. For your first task, you are supposed to place the words that are on the screen in a flowchart to organize them according to their places as far as types of matter and then characteristics of those types of matter. And so since our overall theme of this chapter is matter, it makes sense that it would go at the top. Plus, I've drawn this on the board multiple times. So, matter is what we've been talking about this whole time. And then our two different types of matter were mixtures and pure substances. Okay, that's what we divided our little cards into. And so those are your two types of matter. So then on your next row, you had kind of subcategories of mixtures and pure substances. So pure substances can be elements or compounds. Remember that elements combined together make up compounds. And then mixtures can be either homogeneous, when they look the same throughout, or they can be heterogeneous, where you can tell the different parts of it. So then the next logical step is just looking through your words and finding out which ones go under your elements and compounds. So elements, we said that they are made up of all the same type of atoms because sodium is just one thing. So it's made up of the same kind of atoms throughout the whole thing. A compound though, like we talked about several examples, the main one that we talked about was water, which is H2O, and that was two different atoms, hydrogen and oxygen, chemically bonded together. And then for our homogeneous mixtures, they have a different name, okay? So they are also known as solutions, so that goes underneath that one. And then for heterogeneous mixtures, we talked about suspensions and we talked about colloids. So now out of the words I had left, the same atoms or anything off the periodic table, one type of those was oxygen. Oxygen is on the periodic table and it's just one thing. And then for a compound, our classic example, water was up there, H2O. A solution is something that is blended evenly throughout and you can't tell the different parts. So soda or pop is an example of that. A suspension was like pond water, that's the example I think of, and those particles settle to the bottom, so they settle out. And then colloids exhibit the Tyndall effect, where they scatter light. So on our next level, under element, the only other thing that can go under there was hydrogen. It's another type of element. And then notice that these two elements here made up this compound. They're both there, but they're chemically combined this time, which is why it's a compound. And another solution, I thought of an example because I had an extra box here, so I figured why not. Salt water is another good example. I can't tell the salt from the water. And then for a suspension, we talked about pond water or muddy water is a good example. And then colloids, one of our examples was fog. Now for our last three boxes, we're talking about particle size, which was a chart in your notes. So if you just looked in there, you could find it. Homogeneous mixtures are not capable of being told apart. So in pop, there's lots of different ingredients like sugar and coloring and carbon dioxide and all sorts of different things, but I can't tell what they are. So those particles have to be the smallest. For a suspension, I can definitely see the different parts, and I know that they're going to settle to the bottom, so I know that they're big and heavy, so those have to be the largest. And then a colloid is somewhere in between because they don't settle out, but they do scatter light, so they're kind of in the middle. For this section, I just went through and thought of everything and to see what it was made up of. And some of these are kind of difficult, but it won't be this hard on your test. So if you're looking for a compound, remember to look for a mixture of two elements, something like this. That's how it'll be on your test. And if you're looking for an element, they'll have a symbol like this that comes off of the periodic table. Or you can just read it, calcium, one thing, okay? And we know that if it's one thing, then we can look on the periodic table, and if it matches up, then we're good to go. Anyway, nail polish is a compound. It's called acetone. Sugar is a compound. Sodium is an element. Pulpy orange juice, so you have something to fall to the bottom, which means suspension. Salt water was on our front page. It is a solution. Jello is a solution. Calcium is an element. Carbon dioxide, classic compound. Italian dressing has all of those different parts that we can see that end up falling to the bottom, so you have to shake it. So that is a suspension. Latex paint is a mixture. Okay, definitely a mixture, and we can't tell the different parts apart. So solution. Rust is a compound, two different elements. Iodine is an element. Air is a mixture that we can't tell apart, so it is a solution. Kool-Aid is a solution. Copper is an element. Pop is a solution. It was on the front page. Baking soda is actually a compound. Ketchup is a mixture that doesn't settle out, so colloid. Smog is a colloid as well. It works kind of like fog. And then magnesium is an element, silver is an element, and mayo is a colloid. All right, for part 3, you're supposed to circle the correct word or phrase to make the statements true. And so the first one, it says changes to matter in which the identity of the substance does not change. If the identity does not change, that means it has to be physical. Number 2 says, in this type of change, new matter is created. If you create something new, it has to be chemical. Number 3, reactivity of a substance is an example of which type of property. Reactivity means that they're going to interact with something else to create something new. And so that means it has to be chemical. Number 4, food that is spoiling is an example of what type of change. That spoiling food is much different than the original, so that means it is something new. So chemical change. Part 4, you're supposed to mark each of those as a physical or chemical property. The difference between a physical and chemical property is a physical property is one that you can observe without changing the identity, and a chemical property is one that you observe that changes the identity. So, I've marked all of these. And so, number 1 is chemical, because if you light something on fire, you're going to come up with something new. Number 2 is physical, because I can observe aluminum melting without changing aluminum. Liquid aluminum is still aluminum. So, number 3 is physical, 4 physical, 5 physical. Density is a physical property. We can observe it without changing the identity. Acids are corrosive, which means that they basically they eat substances. So can't observe that without them creating something new. Paper is 8 inches wide, is physical. Gold is malleable, which means you can hammer it into a different shape. So that's physical. And then arsenic is poisonous, is chemical. For part 5, you're identifying physical and chemical changes. So if it's a physical change, the identity of the substance will stay the same. If it's a chemical change, you're going to create a whole new substance. So looking at all of these, I've identified them as physical and chemical. For part 6, you're supposed to answer the short answer questions. For number 1, this is something that came straight out of your section 1 notes. So if you were not lazy and you copied down notes, then you have this table. So I'm not going to recopy it for you. Number 2, why do the words shake well before using indicate that fruit juice is a suspension? And why are those words not on a milk container? Well, if it tells you to shake well, that means that the particles are probably settling out. And if something settles out, that means it's a suspension. And then Milk is not a suspension. Milk is a colloid, so the particles don't settle out, so that's why it tells you don't have to shake it. So is evaporation of water a physical or chemical change? So you have to think in terms of, does it create a new substance? So evaporation of water is liquid water going to water that is a gas. But notice I said water both times. So it has to be physical. Water vapor is still water. We haven't created anything new, so it's a physical change. Number 4, identifying 4 physical properties that describe something, and then identify 1 chemical property. So physical properties are something that you can observe without changing the identity. So anything that you could measure or see by looking at something, those would be physical properties. So things like color, shape, size, the mass, even density, because we can measure that and it'll still be the same substance. For a chemical property, it has to be something that's going to change the identity, and flammability or burning is always a classic for that one. Number 5, explain how the law of conservation of mass applies to chemical changes. Well, law of conservation of mass says that mass cannot be created or destroyed. So during a chemical change or chemical reaction, the mass that you had before the change equals the mass after the change. For number 6, carbon, hydrogen, and oxygen combine to form sugar. How do you know sugar is a compound? Well, I could tell right away because we listed 1, 2, 3 elements and it said that they combine. So that is definitely compound. More than one element combined together. And then your last part of your study guide. The review part, we're going to go over scientific method a little bit again. So independent variable could be the thing that you're testing. In other words, the thing that the scientist is in control of. Dependent variable is the thing you measure. Control is something that stays the same so that you can see the difference of the thing that you're testing. And constants are just that, things that stay constant. Study hard, guys. Test on Tuesday.